Hi everyone, this is Jakub Staroń here, and this is the next episode of MedChem Essentials seminars. Today we continue talking about permeability with the focus of permeability assays. Today's presentation will begin with some introduction of basic concepts. Then some assays like PAMPA, CACO2 and MDCK will move on to the summary comparison of these assays and present some example data. So, last time we introduced the composition of a membrane and also basic mechanisms like paracellular, transcellular of compounds that is present during the permeation of the membrane. Here, to describe and discuss different assays, we need to name both sides of the membrane. So we have the outside of the membrane, it's called apical side. The inside is called basolateral side. A transfer between apical and basolateral side is called influx. This is the absorption. A transfer between basolateral side and apical side is called efflux. This is the excretion. Usually, in almost every assay, we measure the permeation in both directions. The usual parameter that is being measured in assays is called apparent permeability. So here's the equation that describes it, but we will not describe this in detail. It's not important for us in this presentation. It's important to remember that is the apparent permeability. That's the value that is being measured. Another parameter that is always given is the efflux ratio. This is the quotient of apparent permeability in both directions. So we have quotient of apparent permeability from B to A divided by apparent permeability of A to B. The apparent permeability value, to interpret it properly, it's always good to have some reference. So propranolol, for instance, can be used as a high permeable reference with permeability of 5. Mannitol is a low permeable reference with permeability of 0.3. The literature says that minimum apparent permeability to obtain 100% absorption in humans is equal to approximately 2. In permeability assays, we have different options. Like the compound can be a transporter substrate. So if a drug is a transporter substrate, it will have concentration-dependent uptake. So with varying concentration of our test compound, we will see different permeability. Or efflux, that is reduced by known inhibitors of that transporter. Another option is that the compound can be a transporter inhibitor. So if a drug is a transporter inhibitor, it will reduce the uptake or efflux of known substrates of that transporter. The first assay to introduce here is PAMPA. PAMPA is short of Parallel Artificial Membrane Permeability Assay. This is purely artificial assay. So we have an artificial membrane composed of 3 fatty acids, cholesterol, synthetic ceramide analogs. Technically, it looks like this. We have 2 compartments, a donor well, acceptor well. Between them, there is the artificial membrane. We introduce the compound here, and we incubate for some time, and then test how much of the compound move to the acceptor well. PAMPA has the advantage that it avoids complexity of active transport. There are no enzymes, no transporters. So compounds can be ranked purely on passive permeability alone. The advantage is high throughput. It's very simple. We don't need to wait any incubation, any growing of cells. We just order prepared plates and perform the assay. But also the advantage is also a disadvantage of PAMPA because it lacks paracellular porous, influx, efflux transporters, and metabolic enzymes. Next assay to introduce is called CACO2. This is short of human colon adenocarcinoma cell line. So these cells, they are columnar polarized cells. They express microvilli on the apical membrane. They have tight junctions between neighboring cells. So it's just like epithelial cells in the intestine. But tight junctions here are smaller than human intestine. So hydrophilic small drugs that rely on paracellular transport might not be properly measured in this case. Technically, it looks the same way as Pampa. We have a donor well, acceptor well, and cells grown in a well on a simple membrane. These cells, they express almost every intestinal transporters and enzymes because, these are colon cells. Important to know is that if the apparent permeability from A to B is not equal to apparent permeability from B to A, or apparent permeability will decrease with increasing compound concentration, then the compound might be substrate of transporter pathways. We already mentioned this previously. We just highlight that in this case it's highly important to remember. Also, if the efflux ratio is equal to above 2, then the compound is the substrate of efflux transporters. To have final confirmation whether the compound is really a substrate of efflux transporters, we can use inhibitors of these efflux transporters. So when those inhibitors will be applied and we will see a change, usually like a change of the readout, then that will be a confirmation that the compound is a substrate of this particular transporter. The next assay is called MDCK. MDCK is based on Madin-Darby kidney epithelial cell lines. Technically, it looks the same way as CACO2, so we have cells grown, apical side, basolateral side, and the compound just travels through the membrane. Usually, we can note similar values between CACO2 and MDCK, these cell monolayers. The MDCK, they were transfected with MDR1 gene. You may recall from previous presentation that this is a gene that encodes PGP transporter, the primary transporter that is responsible for multi-drug resistance of cancers of organisms. So MDCK have very big advantage over CACO2. They have much faster growing time and looser tight junctions. So comparatively, CACO2 is based on human colon adenocarcinoma. This is canine kidney cells. Cell morphology, this is intestinal epithelium. This is like from kidney, distal tubule epithelium. This can be slightly different. But here is the marked difference. It takes 2 to 4 weeks to grow these cells, whereas here it's 3 to 7 days. This also transfers to lower cost of MDCK. Uptake transporters, SCACO2 expresses every transporters found in the human epithelium, intestinal epithelium. MDCK, most of them, not all of them. Efflux transporter, the most important PGP, and other transporters efflux are expressed in CACO2, and those transporters were also transfected into MDCK cell lines to be also expressed. So both the MDCK and CACO2 assays, they produce comparable results with non-PGC substrate and compounds with low and medium permeability. The practical advantage is what I mentioned a moment ago, is that MDCK have faster cell proliferation and differentiation, which reduces the time required to conduct these studies. There are some limitations of every of these assays. One is that a drug which has very low aqueous solubility will be difficult to assess, as these living cells, they may not tolerate some higher, even moderate quantities of organic solvents. It will just kill the cells and destroy the assay. Additionally, any toxic drug can affect the monolayers. So any cytotoxic drugs can actually disrupt the readout, disrupt the assay. Also, test and protocol compounds can bind to plastic culture apparatus and be retained within the cell monolayers. That will affect also the final readout. Also, cell assays are static and they lack the intestinal motility found in vivo. How our intestines move when we move actually affects the permeability, possibly increasing it. And here, these artificials very much simplification of the actual living situation. And furthermore, drug transporter expression, the cell lines between different laboratories can slightly vary. So it may likely we can compare between laboratories, compare compounds. If something is high in one laboratory, it will likely be high permeable in another laboratory, but if we compare the values themselves, they may be slightly different. And here are the example data from MDCK measurement. We have some test compounds. We obtained values for permeability from A to B. These are, as you can see, likely most of them are rather low permeable compound. And we have B to A. This is highly permeable, so the compounds very likely are efflux substrates for efflux transporters, because the efflux permeability is much higher than the influx. We also have reported recovery. So this is the ratio of a compound that is found in the compartment after the assay to the amount of compound that was delivered to the assay. And we can have below 100%. In ideal situation, this will be 100%. But here is like much lower, like 66, 75. So likely the compound, either it bound to the plastic or bound maybe to some cell components, and this affects the readout. So if the recovery is low, it will affect the quality of the readout. Also, with every assay, we measure some controls to confirm that everything was fine with the assays themselves. And in this case, aprenavir was used as a low permeable compound, 0.5, and diclofenac was used as a highly permeable compound, 28.7. The efflux ratio of diclofenac is 1.1, which means that the compound is not a substrate of transporters. The efflux ratio of these compounds is, in some cases, very much above 2, so very likely the compounds are substrates, very effective substrates of these transporters. On every report, we'll have also classification. So here below 2, compounds are being classified as low permeable, and compounds with permeability between 2 and 10 as moderate, and above 10 as highly permeable. Also, there will be a remark that a compound of efflux ratio above 2 is a PGB substrate. Thank you very much for your attention, and see you next time.